Time and time again, men in research have discovered that an idea which has been discarded as obsolete comes to the fore again when retested with modern materials. So it is that the non-recoiling cannon, which went out of date at the turn of the century, has been found in tests at Aberdeen Proving Ground to have a design practicability today. Common sense in the early 1920s forbade the mounting of a non-recoiling high-caliber weapon on a self-propelled mount. The shock of firing the weapon was too great for the mount. The jar could damage the equipment and cause casualties to the operators. The idea was abandoned, but the Automotive Division Development and Proof Services conducted a series of tests employing 75mm and 76mm non-recoiling guns and self-propelled tracked vehicles. The overall finding at this time was that the system was entirely feasible. Possibly the reason for the finding was that the more massive the vehicle used for mounting the gun, the better the weapon performed. Compared to a standard recoiling weapon, this type of piece could be much simpler, cheaper to manufacture, and cheaper to maintain. Recently, at Aberdeen Proving Ground, a similar series of tests was conducted with a 90mm non-recoiling cannon mounted in an M47 tank and compared with the same diameter recoiling cannon in a like vehicle. The 90mm projectile weighs 15 pounds and the M47 tank approximately 50 tons. The non-recoiling weapon was a standard 90mm gun with a strap around the breech, making the entire mount rigid. The purpose of these tests was to accurately compare the actual amount of stresses on the turrets of the vehicles and their operating crews. The recoiling weapon shown here being fired rolls with the punch, so to speak. In contrast, the gun in a fixed mount jolts the vehicle, but total movement is less than in the recoiling type of mount. Inside the turret, the breech of the non-recoiling cannon reacts like this and causes the camera to vibrate severely, while the recoiling weapon performs normally. The guns were fired at various elevations ranging from a minimum of +2 degrees to a maximum of +18 degrees. There are different effects on the suspension systems while firing the two different types of weapons. This during the firing of the recoiling 90mm gun, and here, the non-recoiling 90mm gun. Accelerometer tests were taken at various points on the turrets of the tanks, and the longitudinal shock results recorded here for comparison. At the bustle, the force recorded was 4.5 Gs for the recoiling type and 74.8 Gs for the non-recoiling. At the breech, the record showed 301 Gs for the recoiling type and 347 Gs for the non-recoiling gun. At the rangefinder, the force was 23.5 Gs for the recoiling type and 71.2 Gs for the non-recoiling. At the commander's periscope, there were 8 Gs for the recoiling weapon and 80.3 Gs for the non-recoiling. The effects on the operating crew, specifically the gunner, were recorded in a similar manner. Accelerometer gauges were attached to a harness and strapped to the gunner. There was a marked variance in the shocks experienced from the recoiling and non-recoiling types of weapons. These shocks were measured also in Gs, for example, 32 feet per second per second. At the head, the longitudinal shocks for the recoiling weapon were 1.2 Gs and the non-recoiling 2.5 Gs. Also at the head, the vertical shocks for the recoiling weapon were 0.6 Gs and the non-recoiling 2 Gs. At the chest, the longitudinal shocks for the recoiling weapon were 0.6 Gs and the non-recoiling 2.2 Gs. At the helmet, the longitudinal shocks for the recoiling weapon were 4 Gs and the non-recoiling 8.9 Gs. From the point of view of wear and tear, human beings seem to take the reactions from the firing of the non-recoiling weapons better than the turret components of the tank. Part failure was a regular problem. Detroit Arsenal and Automotive Division engineers have concluded that because of the advantages of non-recoiling weapons, especially lower initial cost, easier maintenance of existing guns of this type, and a possible lower silhouette because of space saving in the turret, their use is practical. The most pertinent recommendation is that a turret be designed specifically for the non-recoiling cannon, one capable of absorbing the forces encountered that cause the shortcomings found in adaptations made from present design.